Guys, and welcome back to another lesson in Algebra 1. This is Unit 5, Lesson 5, and it's about taking our linear equations and applying them in a real-world context. So today's objective, you know you are successful when you can write linear equations in any of the three forms when given a word problem. And you'll end up choosing the form that fits the information given. So we do have our three forms that we talked about here, and then we can also be given 2 points, and we need to kind of tweak that a little bit to work with. So first, slope-intercept form, you are going to use this when you are given a slope and a starting amount. And we'll show what that looks like, in the word problems below. Okay, so how you'll know to use the point slope form is what'll happen is you might be given, oops, let's see, that's a little messy. You might be given two different rates for two different amounts. And I would strongly suggest that you define your variables so you do not get confused. It's super easy to get confused on those. And then standard form, how you'll know to write an equation in this form is going to be when you are given a point and a slope. Okay. Now, sometimes they can give you 2 points instead of a slope, and that's no problem. We can use those points to calculate slope. And so, I gave you the slope formula up here, and then you can write the equation either in slope-intercept or point slope. Okay, and if I am going too fast, just pause it. I'm going to go to the example because I am recording this ahead of time. Okay, so what does this look like in practice? Well, let's read this problem and let's see if there's anything that is important that we can get out of this problem. It says Alex is spending an average of $8 per day. That sounds like a slope, okay, because it's a rate. You're earning $8 per day. And then after 5 days, Alex has 96 left. That sounds like that's actually a point. And so they said to write a linear equation. And then our second question, we got another question here. Actually, we'll just go ahead and deal with writing the linear equation, and then we're going to come back to that. Okay, so I can tell by looking at this that my slope is $8. And he is spending, okay, so that's going to be implying that he has a negative slope, right? Because he is spending that, he's giving that money away. And so we have a point here where where our x value is 5 and our y value is 96. And let me just go ahead and take a point here. I'm going to define my variables with a let statement. This is really good practice to keep everything straight in your head. So my x, we're going to define that as days. And my y, we're going to go ahead and define that as, money that's left over. Okay. So we want to write an equation. Well, when we have a slope and a point, we know that we can do point slope form. So let me go ahead and grab a different color. So we're going to use our point slope equation. And remember, that's going to be y minus y1 equals mx minus x1. And then we're just going to simply plug these numbers in. So I've got my y minus my y1, which is 96. My m is my slope, that's at -8. And then I'm going to do x minus my x1, which is this 5. And that's my equation. So we've written our linear equation. But there is a second component to this. They want us to go on and find out how much money Alex will have left after 9 days. Okay, so that is like a part B to that. Okay, so part A was this. We found our equation. And then part B, after 9 days, this is going to be when x is equal to 9. You know, we're asking how much money is left over. So we're going to plug that in. So we're going to take that 9. We're just going to plug it in right here. And we've got y minus 96 equals -8. 9 minus 5. And then now we're just going to do some algebra. 9 minus 5 is 4 times -8. Y 96. That -8 and times 4 is going to be -32. Let me go ahead and I'm just going to erase this here. I'm going to write -32 here. Okay. I'm going to add 96 to both sides to get that y by itself. And so that cancels, and I'm left over with y equals some dollar amount. So -32 plus 96 is going to give me $64 left over. So after 9 days, Alex has spent that amount of money. So that's how you do that problem. Let's go look at the next one and let's go read it and see what it's asking us. It says a delivery cargo truck or a delivery truck with no cargo weighs 3,000 pounds. Okay, this kind of sounds like a starting amount to me. Like a truck with no cargo weighs 3,200 pounds. Okay, that sounds like a starting weight. Each crate weighs 45 pounds. We're going to write and solve a linear equation, and there is a part B, but we're just going to start with our part A first. We're going to write our equation. And so I'm going to write down what is important here. I know that my start is 3,200 pounds. And I know each crate weighs 45 pounds. That sounds like a slope because there was no other number given with it. So, you know, we just know each crate is 45. So we can do slope is 45. Okay. And so it'll be like how much the truck will weigh overall. So if we're, you know, we're thinking about what it's going to be weighed after you've got 18 crates, but that's our next problem. Let's go ahead and define our variables. Oops. I'm going to write the let statement. I'm going to write let x equal, well, x is going to be my number of crates. Okay. And then my y is going to be the total weight. Okay. So let's go ahead and put this into an equation. Because we have a starting amount and we have a slope, we can do the easiest equation of all is we can write slope-intercept. Okay. So let me remind you what your equation looks like here. It looks like y equals mx plus b. A b makes a really good starting point. So we're going to do plus 3,200 because that's what we're starting with. Okay, we can even label that here. We can say that's what we're starting with. So that's why we plug that in here. And then our y, we don't know what that is. Mx, so our slope is 45. For every new crate, that is put on there, another 45 pounds is added. Well, let's look at our second part here. They gave us like how much will it weigh when there's 18 crates loaded? Okay, so they're giving us another layer on that. They're saying when X equals 18, what does Y equal? Okay, so we can plug in that 18. We can go Y equals 45 times 18 plus 3,200. Okay, 45 times 18. Let me grab my calculator real fast because, let's see. 45 times 18, I have 810 plus 3,200. And then when we add those two together, we should get 4,010 pounds. That's how much the truck weighs once we add all those crates. Okay, okay, so you've seen an example where we used point slope, and you've seen an example where we've used slope intercept. I'm going to go ahead and clear off my page. If I'm going too fast, pause it. All right, let's look at this next problem. It says Maria is buying fruit for a smoothie. Strawberries cost $4.25 per pound. That's strawberries. And bananas cost $1.95 per pound. Maria has $68 to spend. So they want us to write a linear equation. Now notice this is written with different kind of information. We have a rate for strawberries and we have a rate for bananas. That means that we're going to use a different kind of problem or equation in this case. Let me go ahead and define my variables real fast so I don't get things confused in my head. I'm just going to say X is going to be strawberries. And then Y is going to be bananas. And these are both pounds. Okay, so remember that's pounds. We're not counting strawberries and bananas. We're doing pounds. Okay, so the easiest thing here in this case is we're going to have $4.25 times every pound of strawberries plus $1.75 times the number of pounds of bananas, and that's going to add up to 68. When we write it this way, it is very clear the only way to write this is in standard form. Your AX plus BY equals C. Okay, so we used, let's see, standard form for this. And you can see with the three examples how each one looks a little bit different, you know, for how you're going to write it. All righty, so let's look at the next part of the problem, the part B. And it says, you know, how many pounds of bananas can she buy if she does 10 pounds of strawberries? So I need to go update my information here. We're going to write 10 pounds of strawberries. Remember, I define my X as my strawberries. So we're going to say X is 10. And when X is 10, you know, what is my Y? Okay, so I'm just going to write 425 times 10 plus $1.75 times Y equals 68. So I do a little bit of math. I get 42.5 plus 175Y equals 68. I move this over. So that cancels. I get $1.75, and I'm being very careful to try to not lose my decimal because, you know, my writing's not perfect and it's really easy for that decimal to just float away. And so when I do 68 minus 42.5, let me grab my calculator. That gives me 25.5. Okay, we're going to divide by $1.75. So what we're saying here in this equation is that after she buys those strawberries, she has $25.50 left to spend. So how many pounds can she of bananas can she buy if she has $25.50 left to spend? And so we're going to get y equals, let's see, 25.5 divided by 1.75. That's going to give me 14.6 pounds of bananas. And notice I'm writing my label with this too because it matters. Like what does that 14.6 mean? It means pounds of bananas. It has a definition. So we definitely are going to write our units in these kinds of problems. All righty. Let's look at this next one and let's see how what's going on with this problem. Okay, it says a movie theater charges a service fee plus a cost per ticket. So if Jamie buys 3 for 39 and Taylor buys 7 for 71, we want to write and solve a linear equation. And you're like, oh my gosh, I can't tell what I'm supposed to do. I got 4 numbers. Well, think about this. This is going to be our 4th type that was up there in the notes. This is going to be when you have 2 points. Okay. We have 2 points. The first one is Jamie's point. We have for every, for his 3 tickets, he spent 39. And then we have Taylor for their 7 tickets, they spent 71. Okay. Now that we have our 2 points, we can easily calculate slope. Remember, slope is going to be y2 minus y1 divided by x2 minus x1. And so my y2, I'm just going to go ahead and take my 71 minus my 39. x2, I'm going to take the 7 minus my 3. Okay, and so 71 minus 39 is going to give me 32. 7 minus 3 is going to give me 4. 32 divided by 4 is 8. Well, what on earth does that 8 mean? That slope has units with it. It has value. So we're saying that it costs $8 per ticket. Okay, that is my slope. I don't have to put those units in when I make my equation, but I just want you to know that number has value. And so knowing how much Jamie spent and how much Taylor spent on their tickets, it allows us to figure out the cost per ticket. Okay, so let's go ahead and create our equation. Now, because we have 2 points, let me see if I can clean this up a little bit. Since we have, no, it's not going to let me clean this up a little bit. I'm going to have to erase it. Since we have 2 points, we can go ahead and we have now our slope. We can use point slope. So remember, this is going to be my y minus y1 equals m x minus x1. Okay, so my y1, I'm just going to go grab one of these. That's 39. Because I grabbed that 39, I know I have to get the x that went with it. That was the 3. So this is my equation. Okay, we've written my equation. Now what they want us to do is they want us to find out how much it would cost to buy 12 tickets. Okay, so now we've got another layer to this. Our tickets is going to be the X. The X is going to be my tickets. And my Y is going to be the dollar amount. That's going to be the cost. I should have defined this already. And this is one reason why we define our variables, because you'd be like, where do we put the 12 in if we didn't define what was X and what was Y? Okay. So I am going to take my 8 times, my X is 12 minus 3 equals Y minus 39. Okay, so 12 minus 3 is 9 times 8 is 72. And we got Y minus 39. We're just going to add 39 to both sides. And that is going to give me a grand total cost of y is 111 for 12 tickets. That's how we solve that. So until next time, I hope you have a great day, guys. Bye.